triangles, 3 sides. Quadrilaterals, 4 sides. There are 6 types of them that you need to know. I am a little bit excited. Right, here we go. Square, rectangle, rhombus, parallelogram, trapezium, and kite. Let's start with the square. All 4 sides of the square have equal length. They also have 4 equal angles, all of which are 90 degrees. There they are. They have 4 lines of symmetry, one here, one here, one here, and one here. They also have rotational symmetry order of, well, there's 1, and 2, 3, and 4. So rotational symmetry order of 4. Rectangles are a bit like squares that have been stretched. Here's one. They have 2 pairs of equal sides. So this side and this side, and this side and this side are equal. All 4 angles are right angles. There they are again. They have 2 lines of symmetry. One here, and one here. They also, if we rotate it, you'll see have 2 positions where they look the same as you rotate them. So they have rotational symmetry order of 2. Here is a rhombus. It's just a square that's been pushed over. These arrows here mean that the sides are parallel. This just means that they face the same way. So this side and this side are parallel, and, as you see with these arrows, this side and this side are parallel. So it has 2 pairs of parallel sides. If I spin it round like this, you'll see why it's also called a diamond. It has 2 lines of symmetry, one here and one here. And just rotate it round. 1 position where it looks the same. 2 positions where it looks the same as you rotate it all the way. So it has rotational symmetry order 2. Time to look at a parallelogram. Here's a parallelogram, and it's a fun word for a rectangle that's been pushed over. Like a rhombus, it has 2 pairs, one there and one there, of parallel sides. Only unlike a rhombus, it has no lines of symmetry at all. Just rotate it around here. There you go, 1 position where it looks the same. 2 positions where it looks the same as you flip it around, so it has rotational symmetry order of 2. What about trapeziums? There's one, and there's another one, and there's a third one. All trapeziums have 1 pair of parallel sides. There they are. Most trapeziums don't have any line symmetry, but one type of trapezium does. It's an isosceles trapezium, and it means that these 2 angles are the same, and there's the line of symmetry. So most trapeziums have no lines of symmetry, except isosceles trapeziums, which have 1. However, no trapeziums have any rotational symmetry. Finally, there are kites. Here's one, and they have no parallel sides, but this angle and this angle are the same, and they have a line of symmetry down here. When you draw it, you can see that a kite really just looks like 2 identical triangles, this one and this one, that have been stuck together, either side of the line of symmetry. Kites don't have any rotational symmetry though. Another super handy table for you, showing all the properties of these different types of quadrilaterals. As you go down, the pairs of parallel sides get smaller, lines of symmetry get smaller, and the orders of rotational symmetry get smaller. Other than that, it's pretty self-explanatory, except this little note here, where it says trapeziums have no lines of symmetry. That's almost true, except for isosceles trapeziums, which of course have 1 line of symmetry.